Stoichiometry. This is a step-by-step computation. Stoichiometry is the quantitative relationship between the reactants and products in a balanced chemical equation. A balanced chemical equation provides several important information about the reactants and products in a chemical reaction. Molar ratios. For example, 1 mole of nitrogen plus 3 moles of hydrogen will yield into 2 moles of ammonia. These are the different types of molar ratios in stoichiometry. Determine each mole ratio below based on the reaction shown. 2 molecules of butane plus 13 molecules of oxygen will yield into 8 moles of carbon dioxide plus 10 moles of water. Stoichiometry allows us to predict products that form in a reaction based on amount of reactants. The amount of each element must be the same throughout the overall reaction. For example, the amount of element hydrogen or oxygen on the reactant side must equal the amount of element hydrogen or oxygen on the product side. Stoichiometric calculations. Stoichiometric calculations can be classified as one of the following: moles of compound A and moles of compound B. So that is mole-to-mole calculations. Mass of compound A, so that is mass to mole calculations. Then we have mass of compound B, so we have mass to mass calculations. Let's have an example of mole to mole calculations. Relates moles of reactants and products in a balanced chemical reaction or equation. How many moles of ammonia can be produced from 32 moles of hydrogen? Assume that nitrogen is an excess. Example number 2. In one experiment, 6.8 mole of ammonia are prepared. How many moles of hydrogen were used up in this experiment? Let's have mass mole calculations. Relates moles and mass of reactants or products in a balanced chemical equation. How many moles of ammonia can be produced from the reaction of 125 grams of nitrogen? Now let's have mass-to-mass calculations. Relates mass of reactants and products in a balanced chemical equation. Example: what mass of carbon dioxide will be produced from the reaction of 175 grams of propane, as shown?